Okay, salam alaikum, shabab. Welcome back to the class. Ya akhwan, before I start my lecture, I would like to make a few announcements. Maybe it's better to do them in the beginning rather than the end. The first one is about the quiz. The quiz is scheduled tomorrow. Not tomorrow, day after tomorrow, I mean on Thursday. Inshallah, today we will finish chapter number 4, and on Thursday, we are going to talk for about 15 minutes about chapter 6, introduction. And then on Sunday, we will finish the part of chapter 6, which is supposed to be included in the midterm. The announcement that the midterm will include everything until Sunday class, okay? The Sunday class on chapter number 6, which is fatigue. What you should know also is that I am going, inshallah, today to finish the the quiz grading, and I will post it for you. The solution is already posted, but I will finish the grading. Also يا أخوان بالنسبة للquiz والmidterm. For the quiz, in order to prepare you for the midterm, the regulation or the guideline that the university is trying to impose on us is the following. They want us to make sure that we can monitor you while you are conducting your exam. So what is the recommendation is the following. In the day of the quiz راح نجرب هذه التجربة في الكويز on Thursday عشان تكونون مرتاحين وتفهمون الطريقة في الميدترم ما تصير عندكم مشاكل. In the quiz, what are we going to do? I would like every one of you that lecture to enter or access Zoom through the mobile phone. كلكم. No laptop, no desktop. كله بالجوال. And when we start the quiz, you can switch on your, you can join both by your phone and your desktop. عشان when you see my lecture, you can see it on a bigger screen. Now, when we start the quiz, you will switch on the camera on your phone. You will put the phone, ya shabab, not in front of you. You will put it in the side, down. يعني جيب لك مثلا box أو حاجة كتاب واسند عليها الجوال بحيث إنه الكاميرا الأمامية للجوال is casting you while you are conducting the quiz. Why? This is what's going to happen in the midterm, and you need to get trained for it before we do it in the midterm. I don't want you to suffer in the midterm. I don't want you to have any problem. We want it to be practice as usual. Okay? So you can do your quiz on the blackboard, on your laptop, but the camera, the Zoom meeting should be done through your webcam of your phone. عرفتوا يا شباب؟ اللي هي what is it? Selfie camera, okay, of your phone. Now, this will ensure that all students are complying with the regulation. No headphones, okay? No material, no people around you except your textbook and the exam sheet. Now, some of you will ask a question, how can we submit the solution for written problems? Well, the thing is, we are going to make the exam in such a way that you will get the question number 1, you will solve it in a piece of paper. نفترض إنه the question number 1 is a written problem. There will be multiple choices, but for a written problem, you will write the solution. You will have maybe 15 minutes for one problem. So what is going to happen? You will have the 15 minutes. When the 15 minutes finish, you will move to the next problem. The solution that you wrote, just keep it on the side and then go to the next problem, solve it. And then the other problem, solve it. By the end, when the exam finish, خلاص, all problems are gone. You will be forced to move from one problem to another. And when all problems are gone, you will receive a link on the blackboard to start uploading your solution. So what do? You take your phone with the app that we recommended for you. You start taking picture of your solutions, whether it is 5 pages, 10 pages, it doesn't matter. We will give you enough time. No racing. You will take the pictures, you will make the document ready, you will transport it to your computer, or from your computer, you will upload it in the Blackboard, وخلصنا. At that time, you can switch off your webcam from your mobile phone. It's okay. And I will be waiting for whatever, 5, 10 minutes, 15 minutes. I will talk to the coordinator. We will decide about how many minutes you will be given to scan your document, upload them in the Blackboard. طبعا اخوان يعني, let me be honest with you. I know some of you will send emails today and say this isn't fair to have a question and then another one, and then we should be going back and forth and so on. It is a coordinated course. Those decisions are made by the whole faculty for all sections, and whether I like it or not, whether you like it or not, everybody will be treated the same. So you understand me? So just relax and do your best. Now, one last thing. Student also sent me email asking to postpone the delivery of the presentation or whatever that we are going to do for the project. I'm going to post this in the Blackboard. It is not important right now. What is important is the quiz next class and the midterm, which is next week. Okay? Good. Now, today we are going to talk about compression members. And yes, yeah, Mohammed, تفضل.
Doctor, can I open the slides in the screen?
I think not. I don't think so. I am going to answer this, but I am pretty sure that while I don't care about slides in the quiz, I think the coordinator sent us the regulation. I need to double check it. And I believe it says verbally that what I should see from your camera is your textbook, machine design textbook, and that's all. So make sure you get ready for that. I will post the announcement. When I post it, خلاص, everybody is accountable. أنا مسؤول وأنتم مسؤولين.
دكتور؟
Yes.
للحين أنا ما استلمت الكتاب.
Why?
أرسلت للبوك ستور قال إنه وداها الرياض، أنا ماني في الرياض. قال تواصل مع البريد السعودي.
أنت لما أعطيتهم العنوان قالوا لك تحط اللوكيشن. Did you put the location?
لا، أرسلها على طول على الرياض.
Why البريد أرسلها على الرياض؟ بأي حق يعني؟ ليش السبب؟ لازم في سبب. هم قالوا إن الكويستشنير تحتوي على جوال والظاهر الموقع، أو فقط الجوال والبريد يتصل عليكم واحد يعرف المدينة اللي أنتم فيها.
والله ما أدري، هذا الحين يتواصلون على البريد ما يرد. عندي كتاب اللي هو على التابلت.
I need to get back to I need to get back to you on this. Okay.
دكتور.
Yes يا محمد.
هل ممكن تعلمونا دكتور يعني كم سؤال written كم سؤال multiple choice وكذا؟
I will get the announcement that will be sent to all students, and I will post it for you inshallah by end of today maximum.
Thank you.
Okay, يلا. We need to start يا شباب. We need to finish chapter 4 today. So today we are going to talk about compression member. If you recall the early discussions of the course, we once talked about columns, that huge column that we see in IKEA and other store around us here. And we said that these mechanical elements or structural elements are basically called columns, and their main purpose is to carry compressive loading. And literally, this is what is all about compression members. So compression members, ya shabab, can fail due to yielding or rupture under compression. And this might be, surprising to some people because they will always think that tension is always the bad guy. But even compression can do harm. So, and what is interesting here, ya shabab, about this definition is the fact that buckling is different mode of failure. So buckling is number two. They can fail by yielding and they can fail by buckling. So what is buckling? Why it is different than yielding? Basically, buckling is this, shabab. I have a ruler now. This is in front of you, if you see it. And with a very little tiny force, when I push the ruler bend. This is called buckling. And what is interesting about buckling is the fact that it has distinct shape, as you see. This is like a wave. And also, it is very much dependent on the geometry as well as the material. So somebody would expect that this is 30 centimeter ruler. If I cut this into a little tiny piece, probably nobody will be able to buckle it. Actually, it will probably, most likely, fail by crushing if you apply very significant compressive loading. It wouldn't buckle, but rather it will be crushed by aggressive yielding. Okay? Why? Well, let me give you a little, thought experiment. If you have a beam like this with a length of, let's say, 1 meter, not millimeter, I mean 1 meter, okay? And you applied a load on it, which is a compressive load, all right? Now, there will be a point where this beam is going to buckle, just like a ruler, okay? Now, somebody would expect that what would happen if I have 10 meter and I apply load? If this is B1 and this is B2, which one do you think is bigger? من هو اللي بتحتاج انك تحط عليه load اعلى عشان تعمل له buckling? B1 or B2? Which one is bigger?
B1.
B1 is bigger than B2. This is a notion, huh? It's just like you feel that. And it is very clear. We experience it in our life with the ruler. You can go to the market and buy 15 centimeter ruler or 20 and see how hard it is to buckle it. And I mean, if you have a 1 meter ruler, you can put a little tiny load on it and it will buckle right away. So length is inversely proportional to the buckling load. So what you should know is that the idea of the length, is this a long beam or a short beam? أنا توني قلت لكم إنه if it is too short, it may fail by yielding before buckling. So it seems like there is, just like the brusher vessel, there is a thin wall and a thick wall, and this is true. Not only this, we will have two different equations for what's supposed to be an intermediate or short column and a very long column, very long one. And we will split these, okay, between long and short. So what is the critical load? The critical load اللي احنا يخوفنا ان احنا we apply it on a column and then it will buckle. By the way, buckling is dangerous. Do you know why? Because it tends to be a sudden deformation in the column. يعني انت تيجي وتعمل structure, you put the column and you start putting your furniture, whatever, on the ceiling in the room above, and everybody down is not noticing anything. And all of a sudden, the column, just like this, do you know that I am now increasing the load, increasing it, but suddenly it buckled. It doesn't give you any sign. So it's dangerous. Sudden things are dangerous. So if we have, by the way, somebody would also expect that if we have a pin end or a fixed end, you know, buckling will be different. It makes a lot of sense. If I have a fixed end and a free end, عمود كذا طاير في الهواء, ما في any clamps, nothing. It looks like it will be more dangerous than some other way of clamping or end conditions. So what happened? There is an equation which is famously known as Euler column formula. I think, I'm pretty sure he is, but maybe I forgot. But this Euler is the same mathematician اللي بالشكم في الرياضيات. وين ما تروحون ينط Euler. Euler ما بغريب عليه ينط عليك من كل جهة, because he's one of the greatest mathematicians on earth, right? So, and Euler جاء بلشكم هنا في الماث. So what did he do? He derived an equation, which is, as I said, called the Euler equation, which is B critical, the critical load, which is equal to C. C is the end condition. It will tell you, it's the reason why we have C for this, which maybe I call it C1 and C2 and C3. So C will tell the equation, what is the boundary condition? Is it fixed? Is it round? You understand? And then by square, it got, you know, no easy than by, you know, 3.14 square. And then the modulus of elasticity E, and then this one, which is I, the moment of inertia, and then the length L squared down. So the proportionality here tells you that L, as L increases, you know, what happened to P? It decreases. So you need less load to buckle something which is very long than something which is very short, which is, you know, very clear from the ruler experiment. E is the modulus of elasticity, so it tells you, you go to Aramco, you go to IKEA, whatever, and they have a column. The first thing you ask them, from which material this is made? Oh, they steel. E is 200 gigapascal. What is the length? I can measure the length. And then you tell them, okay, by observation, you can see, is this a fixed end? Is this a pin end, whatever? And that's it. The moment of inertia is just a moment of inertia. If it is an I-beam, you can easily find the moment of inertia. It's not very difficult. And you will know what is the critical load in kilonewton. This is very interesting. Now, if we divide the critical load as a force by area, then we will have B critical over A, which is going to give us the critical stress, equals to C by EI over by square over L A, so L square A. Now, if you recall, I, the moment of inertia, okay, is equal to A K square, where K square is the radius of gyration. Do you remember the radius of gyration, ya shabab, from dynamics? Which is equal to, K is equal to the square root of I over A. Now, if you do that, you will end up with this relation, which is what? B critical over A, which is a stress, equals to C by square multiplied by E, the modulus of elasticity, divided by L over K square. Now, what is interesting is that L over K, forget about the square, turns out to be very interesting value, okay? That value is what is called as the cylinderness ratio, okay? And you will see that L over K is basically going to determine which way to go. Is this a long column or a short column, okay? So before we move on, let's talk about C. C, as I told you, is very simple. If you have a pin or round end, you will get C equals to 1. If this is fixed, as you see, the slope here is 0, then C equals to 4, which means, ya shabab, that C is going to multiply the equation by 4 And the critical load, instead of having a critical load, which is 1 kilonewton, it will become 4 kilonewton, which is very good. So fixed will improve the column strength. But if you have a free end, as I told you, this is very bad situation. It will divide the equation by 4. C is 1/4. So if the critical load is 4 kilonewton, it will become only 1, which means you cannot apply too much. This is not very nice condition with respect to buckling. And then we have a fixed and round end with C equals to 2. Now, I want you to look at these. Look at this one يا شباب. مو غريبة إن أويلر ينط علينا كذا. ليه؟ الرجال يحب الماث، هو يمشي ويطلع ماث. وجاء وشاف البروبلم هذه وقال لك والله هذه كوساين. هذه ساين equation. وهذه cosine. And if you are really interested, go and open the textbook and you will see the derivation of the differential equation. He just realized that the solution for this end is it's going to form a sine equation, and this one is a cosine. I think this is what brought Euler to us. He was just, دافور يحب الماث واجد. جاء وشاف math problem قال أحلها. Okay. So, however, as Euler is the greatest mathematician, or one of the greatest mathematicians on earth, what he provided us is the theoretical value, which were derived basically on a pure mathematics. We know that if you take a column and you investigate, you try to do an experiment to determine C, and you bring steel or aluminum or any other material, you are not going to get it exact. Why? Because materials are almost always imperfect. صح ولا لا? Dislocation and so on. So it will be different. وهنا تقع المشكلة. وين؟ لأنه جاءوا الناس الديزاينر اللي كونزرفاتيف ولا تفهموها بطريقة نيجاتيف يا شباب. في ناس خواف. تيجي تقول له you can apply for، يقول لك لا 1 only. تشتري سيارة جديدة وتطلع مع الشباب وتطلع من الشرقية بتروح الرياض. and تركبون وياك في السيارة يبلشون فيك. قاعد تمشي فيهم 60 كيلومتر بر اور. ليش؟ لا تخرب السيارة جديدة ما ترضى. This is the same thing. Now, being conservative would save lives and so on. And the conservative value, if you see, this one is not very much different. This one is not very much different. From 2 to 1, from 4 to 1. That's too conservative. So ASTM, other society, civil engineering, and everybody who's interested in column, they start doing too many experiments, and then they came up with recommended values. The recommended value منين نجيبها احنا الانجينير؟ معناها equation حاجة, where reality is something else. And when we did tons of experiments, we realized that there is a confidence around some values of C. So what are the recommended value? For fixed free, 1/4 ما تغيرت. Round is 1. And then for fixed round is 1.2 and 1.2 for fixed. الزيادة ما بين هذا وهذا كم؟ 20%. لا تستصغروها يا شباب. let me try for a second to teach you what does it mean to become a designer. 20% in the factor of safety, or this C, which is going to change the load a little bit. And then the load, in order to make things safe, you might need to add a few millimeter. Few millimeter means you need to add a few grams multiplied by the length, so you end up with a few kilos. الماتيريال بفلوس ما هي ببلاش. You understand? and if you are producing your machine by millions a year, you will end up 20% هذه 20% 1.2 يمكن تطلع معك 100 200 300 ألف كيلو of that material. That's gonna bill you millions extra. So the decision, should you do it or not, is not easy. Should you go with the recommended, with the conservative, is not easy. Do you understand? And of course, this is in terms of money. In terms of applicability, I mean, you cannot just dump material, even if you are rich. Your airplane will never fly if you keep making your material heavier and heavier. So you need to be good. You need to take good decision, huh? ما أقول إنك تضحي بأرواح الناس. All right. So المشكلة الآن, okay, comes from what is a long column and what is a short column. Now, Euler equation, if you recall, which is B critical equals to C by square EI over L square. لو تلاحظون المعادلة هذه ما لها حدود. Doesn't have any boundary. يعني Euler شو يقول؟ يقول لك زيد الاريا, I mean increase the moment of inertia, B critical will increase. Increase, 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 increase. So كأنه Euler يقول لك روح اصعد فوق. You just keep increasing up. But we all know from reality that if you relate B critical A, okay, so you write B critical over A as a stress and then strain, what will happen? The material will end up deforming plastically and the stress will not just go to infinity. صح ولا لا؟ So Euler equation فيها مشكلة. تجي وتقول لك إنه as the cylinderness ratio get lower, the B critical will go up. But the reality is this, as I told you with the small roller, if you make it too small, if you keep applying more and more load, what will happen? It may fail by yielding. And this is what is the truth. So there is another guy who said, no, our limit يا Euler is, يعني صحيح أنت mathematician وعلى راسنا, but you cannot go more than yield. Okay? So he put the line as you cannot go more than yield. And then what did he do? He proposed, this guy is called Johnson. He proposed another equation, which seems to be more realistic than Euler for a limited period. That equation goes like a parabola. And interestingly, as usual, these two equations meet together in one point. This is our point. Oh no. This point is called the critical cylinderness ratio, which is L over K1. فمثلا إذا طلع, لاحظوا, if you are in this side, you use Euler equation. If you are in this side, what do you use? You use Johnson equation. I didn't show you Johnson, don't worry, I will show it to you. So this line will determine if you follow في الحقيقة, يعني this is now the end of it. Let me show it to you. This line will determine whether you follow this curve or you follow this curve. And you need now to know which side should you go. So, interestingly, this L over K1 can be determined using material properties. يعني ما لها شغل لا ب L ولا ب K. احنا نسميها L over K1, but في الحقيقة هي مو function of L over K. Let me show you what. L over K1, this critical cylinderness ratio, is equal to 2 pi square C multiplied by E is the modulus of elasticity, divided by SY. And don't forget the square root. Now, what does that mean? It means the following. Let's again go to Aramco or IKEA or whatever. And then we saw a column. And then we ask them, what is the material? They tell me steel. Steel has a E of 200 gigapascal. And then I tell them, which grade? They tell me 1015 hot rolled. SY for that is 340 megapascal, if I'm not mistaken. Then I look at the column and I say, oh, this is a fixed column. So C, I'm going to use the recommended value, 1.2, for example. That's it. خلاص خلصنا. You can find L over K1. طيب تيجي تقول لي الحين أنا طلعت L over K1. وش أسوي الحين؟ أقول لك تعال الكولوم الحين أنت ما تقدر تجيب ميتر ها؟ measuring stick or measuring tape. Go and measure the length of the column. What is the length of the column? 50 meters. What is the cross section of the column? I beam. Can you find the moment of inertia? Yes, I can. So what do? You find L and I. And then I tell you, go and find A. You find A. When you find I and A, you can find K, which is equal to I over A. صح ولا لا يا شباب? Are you following up?
Yes.
Okay. Somebody spoke at least. Thank you, Salman, I think. So what happened? When I find L over, K, أجي وأقول أنا عندي 50 وأقسمها على الK طلعت ال L over K. Now what do? I compare. نفترض إنه L over K1 طلعت كم؟ 200. وأنا حسبت L over K من الفيزيكال بروبلم طلعت كم؟ 250. What do? I go back. إذا كان هذا 200 وأنا 250 معناها أنا أستخدم أويلر كيرف. لو طلعت L over K 100 مثلا معناها أنا هنا إذا أستخدم جونسون formula. The question is, what is this Johnson formula? Johnson argued, as I told you, إنه yield stress is the limit. So he did it really, literally that way. So he said B critical over A. So Johnson is expressed in terms of stress, P over A, force over area, which is okay. If you want P, you can just multiply the entire equation by A. This is, I think, very simple. And then what he said, we start from the yield. صح؟ هو إيش يقول؟ يقول لك start from the yield. And then you go down. Either you go maximum the yield, يعني إذا كان هذا zero حيطلع معك yield stress. إذا كان هذا البارت not zero, you will be below the yield stress. Do you understand that? So, what is Euler equation? Johnson. He said it is SY L 2 by K square multiplied by 1 over C. And this equation is only valid when L over K is less than or equals to L over K1. Understood? Any question, ya shabab?
No.
Okay, so let's go to this problem. This problem is very interesting. It has two parts. The first part is straightforward. The second part is a little bit twisted and it's more of a design problem. اللي عندنا يا شباب is a compactor هنا, solid waste compactor. This is the solid waste, like a can. And this is the actuating arm. And what do we want? This part, which is going to be under compression, has a length of a height, or a length of 1.5 millimeter. So L is equals to 1.5. Now, what do we want? We have two versions of this. يعني احنا نبي نبيعها للماركت. واحدة ستاندرد حق علب بيبسي وكذا. The other one is a heavy duty. We want to apply 250 kilonewton on it. and without buckling this column. Okay, so what happened? The material is steel, 200 gigapascal. The yield stress is 250 megapascal. And we want to make sure that the factor of safety is 3. So for the standard problem, اللي هو standard geometry, y اللي هو هذا equals to 15 millimeter and x equals to 30 millimeter. وعلى فكرة يعني ترى this geometry is gonna deform like this. يعني if I exaggerate it, it's like this. Do you understand? Such that this is the x and this one is the y. So when it bends in this way, this is going to be the base, the neutral axis. I mean, this is the neutral axis, and x is going to be the base and y is going to be the height. So in the first problem, نبغى نعرف إذا كان الواي 15 والx 30 نبغى نعرف what is the load capacity. إحنا نبغى نحط الطبعة على البوكس when we sell it in the market. This is 200 something kilo Newton or 5 or 6 or 7. So what are we going to do is this. So this is of course the first part. The second part يقول لك نبغى نسوي a bigger version, heavy duty one. الكباسيتي لها 250 كيلو نيوتن 250 بحيث انه الاكس equals to 2y. So علمنا كم مفروض يكون الدايمنشن. This is the heavy duty one. So let's go to the standard one and we will try quickly to solve this without rush inshallah, because this is يعني the last problem that we have in this chapter. So I will start by L over K1, which is equal to what? 2 pi square CE divided by SY and then 1 over 2, which is the square root. C is equals to 1. Why? Because it is pen, round. The value is always 1, whether it is recommended, conservative, so we don't need to worry about it. E is 200 gigapascal, SY is 250 megapascal. So be careful, you divide these right. So let me write it. I think we have time, so let me write it for you. It is 2 pi square multiplied by 1 multiplied by 210 to the power 9 in giga divided by 250 multiplied by 10 to the power 6 and then the square root. What is this value? 125.66. خلاص هذا الرقم ما يتغير. Unless you change the material, unless you change the end condition C or E or SY. It's never going to change. Now, what can we do? Well, the first problem, X, which was the base, was equals to how much? 30 millimeter. Y, which was the height, was equal to how much? يا شباب? 15 millimeter. So I can find I, which is 1 over 12 BH cube, which is equal to 1 over 12 multiplied by 0.03 multiplied by 0.015 as a height, a cube. And then I will get 8.44 multiplied by 10 to the power minus 9 meter to the power 4. Then I can find A is equal to 0.015 multiplied by 0.03, which is going to give you 4.5 multiplied by 10 to the power minus 4 meter square. Now,
Victor?
you can, yes?
Could you repeat how did you identify the base and the height?
Yeah, okay. Now, in here, if you look, okay, let me show you. You see, do you see this diagram? It says that this dimension is the y. إيش معناها؟ معناها هذا الدايمنشن الضعيف، هذا اللي 15 وال30 هو هذا صح؟ Like this. Now this one is 30. If you apply compression in this, what will happen? This one will bend like this. Now, when you look at a beam, you think of it as a beam, and the beam bend like this, and the neutral axis is going to be parallel, صح? To the moment. The moment بتكون like this, صح? So this is going to be the base. Okay, all right. Now, so let's go back here. Now I can find K. K equals to the square root of 8.44 multiplied by 10 to the power minus 9 divided by 4.5 multiplied by 10 to the power minus 4. And this is going to give you 4.33 multiplied by 10 to the power minus 3. And if you find, ya shabab, L over K, now what's going to be? It's going to be 346.42. If this is 346, صح? What should I do? Which is greater than the L over K1. معناها مفروض نستخدم Euler, صح ولا لا? Are we clear?
Yes.
Doctor, how did you get K equal to power or square?
شلون
Is there a
ال K?
formula? Equal.
Oh yeah, of course. We talked about it here.
Yeah. Okay, what is it? Yeah.
I is related to AK square.
Okay, got it.
Okay?
Yes.
All right. Okay. Now, إذا لازم نستخدم Euler. If we want to use Euler, we should be very happy. You know, jump. Euler is easy. B critical is equal to C. C is equals to 1 multiplied by pi square EI over L square. But this is the equation. I need B allowable, اللي هو allowed one. So I need to divide this by the factor of safety. Now C is equals to 1. So I will have pi square EI divided by L square. And if I find this, I will get this as 2.47 kilonewton. طبعا للمعلومية لو تودون هذا لحق الماركتينج تيم وتقول لهم يا شباب حطوا على الطبعة على الكتاب على البوكس ترى الallowable stress 2.47 حيزعلون واجد. You need to find a way. من يشتري هذا؟ قول لي 2.99 or 3 something like that. ما في أحد interested in 2.47, so they will tell you something. You need to manage yourself with it. Okay, this is the first part. It's very easy. Any question?
Yes, doctor. How did you get the factor of safety?
The factor of safety was given in the problem. 3 was given to us. The factor of safety دائما نقسم عليه. ليه؟ لأنه الرقم اللي يطلع معنا دائما نقصه بالفactor of safety نقسم عليه. And it was given to us إنه factor of safety is a 3. So we're always going to use 3. Now let's go to the other problem. The other problem إيش قال؟ قال إنه x equals to 2y. So what are we going to do? We are going to express everything in terms of I or in terms of x. So the solution is I is equal to what? 1 over 12. The base equal to 2y. Well, height is equal to y cube. صح? So the answer will be y to the power 4 over 6. Now, what I am going to do, I'm going to make a bold move. What's a bold move? باجي بقول أنا والله ما أدري هذا البيم طويل ولا قصير. I don't know. And to know if it is long or short, I need to find I need to find A, and then K. I know that L equals to 1.5, but I don't know I and A and K because Y is unknown, X is unknown. So I'm going to assume, ونشوف حظنا يعني, I'm going to assume it is an Euler beam. I'm going to assume it is long. So B allowable will be equals to 1 over factor of safety multiplied by what? The same equation, by square E over L square, okay? Multiplied by I. Why? I just want to break it down. C يا شباب equals to 1. So when I break it down, this is going to be 1 over the factor of safety, which is 3. By is a constant. E is the modulus of elasticity for steel. L is 1 over 1.5, which is given. I here is going to be y to the power 4 divided by 6. Now, if you look at this, pi is constant, L is 1.5. This one is 200 gigapascal. And what? That's it. I can, there's one unknown which is remain, which is y. Why يا شباب؟ لأنه البروبلم الثانية قالت الهيفي duty, the load should be 250 kilonewton. So I know the load. Only unknown is y. I find y, and it turns out to be 47.6 millimeter. Now, am I done يا شباب؟ خلصنا خلاص.
We need to use Johnson.
Why?
To compare.
No. انت يا سلمان؟
Yes.
يا انت متردد يعني مشكك كذا عندك شيء ما هو بعاجبك, which is true. This is based on the assumption that this is an Euler beam. Yes, Muhammad.
Check the value of L over K.
Yes. I need to go. الحين خلاص عرفت الواي. إذا عرفت الواي, A is equal to 2y multiplied by y. If y is 47.6, I can find it. So I'm going to call this one A star. And then y star, don't you remember? It was y to the power 4 over 6. I can find it. Then I can find K star, which is equal to I star divided by A star. And this one turns out to be 0.0137. Now look, I can find L over K star. صح؟ واللي راح يكون 1.5 divided by 0.0137. And what is the answer? 109.16. للأسف طلع هذا أقل من L over K1. يعني معناها إنه my assumption to use Euler is wrong. I need now to go and use Johnson. Do you understand يا أخوان؟ لما Euler equation gave me y, I checked it and it turns out to be the L over K less than L over K1. It means I am in the Johnson equation, not Euler. So what should I do? I go and say B allowable, okay, is equal to the area over factor of safety multiplied by SY minus SYL 2 by K square 1 over CE. Again, allowable هنا 250 كيلو نيوتن. الاريا تذكرون 2y square divided by the factor of safety. This is 250 megapascal. L is 1.5. And again, I will have K, which is what, ya shabab? I need to express K as I, and I know I in terms of Y. So what will happen? I will find Y again. And Y, if I use Johnson equation, Y will become 48.52 millimeter. Now, this isn't very much different, ya shabab, from the 47. But look what happened. If Y equals to 48, if you go find L over K, I'm going to call it star star, okay? What will you get? You will get this one as 107, which is less than L over K1. L over K1 إذا تذكرون يا أخوان كانت 125. 125. So When I use Johnson, Johnson gave me a dimension y. When I go and find A, the area, when I find the moment of inertia, and then find the radius of gyration and divide L by the radius of gyration, I get a ratio which is less than the critical slenderness ratio, which means that the assumption of using Johnson is correct. So خلاص, the solution is done. Y supposed to be equal to 48.52 millimeter. Okay, أخوان. This is the end of the class, and we are just on time. I am going to be available for my office hour if you need anything. Okay, Shabab, thank you so much.